When we talk about measuring smoke, whether from a factory smokestack, diesel engine, or a wildfire, pellet stove, or wood stove, we aren't just counting particles. We are trying to understand how those particles interact with light. The methods we use to quantify smoke pollution rely on fundamental principles of optics, particularly in how light behaves when it hits tiny airborne particles and droplets. In this video, we'll explore two primary optical concepts that are essential for accurate smoke measurement: opacity and the Tyndall effect. 1. Opacity, light blocking. Opacity is the most direct and common method. It measures how much a plume of smoke blocks a beam of light. Think of it as a smoke curtain. The denser the smoke, the darker the curtain, and the higher the opacity reading. This technique is often used in regulatory settings to monitor emissions, as it is directly relates to the visible darkness of the plume. 2. The Tyndall effect, light scattering. In contrast, the Tyndall effect or light scattering doesn't rely on light being blocked, but light being deflected by particles. If the particles are large, it will deflect the entire wavelength, so the light will not change color, it'll just be scattered off to the side. If the particles are very small, it will deflect the blue light, and that shifts the color to the red. This only happens in very small particles like smoke, so the Tyndall effect can be explained with light scattering to the side, but it can also be explained with a change in color. That brings us to this chart. So this chart I'm really pleased with because I didn't do this testing. I provided the instrument and I sent it down to Berkeley and their team tested it. Now, their particular interest is in opacity. And when we started this process, some of the reviews were that a pellet stove would not indicate signs of opacity because it burns so clean. At the same time, I was working on the instrument and had found this color shift variable that comes out of the sensor. And the team really wasn't excited about the color shift. Yes, they would listen to me. However, they were focused on the opacity and the fact that it could read a pellet stove. So let's go over this data and what it tells me, and help you understand what I'm looking at. This is the first 60 minutes of test, and you have to understand how testing works. You got to get started, baselines, about 5 minutes. It looks like they started it, and then they ran it on high. Now, every time a pellet dropped into the cup, you can see a peak of opacity. So that's the blue line, and we're looking at the fire growing, and then every time the system activates the auger, it drops a new batch of pellets in. So every one of those peaks, and they're at regular intervals, is the system turning on and feeding the fire. So yes, we can look at the opacity and smoke released by a pellet stove. It's quite clear what's going on here. The other thing, the red line, is the color shift. And you can see that it does certain things in sync with the opacity. So when you have a strong opacity signal, you'll also get a strong but possibly negative color shift signal. It's a different type of signal in that we're shifting the color to one side. Either red would be up and blue would be down. And sometimes it does shift to the blue, but the peaks generally go up. What I see in the data that I look at is that when it goes into the ember phase, we get a negative or a blue color shift and a very low opacity. So there are different types of data coming in different ways. And when we look at the opacity together with the color shift, we get a clearer picture of the particles leaving the chimney. This is the Lawrence Berkeley National Lab, Solid Fuels Labs test of the Octoring, data set 1 for 3 hours, 60 minutes of on high and 2 hours on low. Now, as a Harmon pellet stove, the data, let's look at the data. For the high phase, we have large opacity peaks. Well, large compared to the baseline. I think they're really only around 10 peaks, which is small. Pellet stoves burn very clean. But let's look after 60 minutes. We went to the low phase, and we have a small amount of opacity that we see. Less than 5%. But the color shifts to the blue during this phase. And we see this on wood stoves where we're in the ember phase. There's not a lot of flaming going on. And we see this shift of about 5 to 8 on the color shift toward the blue. And it's reproducible and measurable in many cases when we're in the ember phase or on low burn. I think it's useful data, and I'm the only one that says this. This is the last little bit of testing for this video, but what I want you to look at is what a pellet stove looks like between 45 and 60 minutes in the opacity range. Every time, almost once a minute, it turns on the auger, dumps a batch of pellets in, and you get a little puff of smoke, and that's what this is reading. Stop leaving your house smelling like a campfire. If you're struggling with a wood stove that's smoky, slow to heat up, and eating through wood, you're not doing it wrong. You're doing it like everyone else does. New tools are coming here for good fires, wisdom, and findings. The final reports from the scientists are coming in.